Greetings to everyone! Today I've decided to do a little experiment and install XLR input into my Jamo D7 subwoofer. I will explain everything in a second, but first I'd like to encourage you to subscribe if you enjoy this type of content and would like to see my videos coming out more often. Jamo D7 is a closed-type THX Ultra 2 certified subwoofer powered with 400 watts D-class amplifier. It has an 15-inch driver with motion feedback sensor. It weighs 33.6 kilograms or 74 pounds. If you are interested, I will leave all specifications into the video description. So, why did I decide to get involved in this enterprise? I'm using Marantz AV7705 surround processor in my setup, and it has balanced outputs. And I thought, why don't I fully utilize this feature? Balanced connections are widely used in professional environments such as recording studios. Before you start spending your money on ridiculously expensive RCA cables made of pure silver with 24 karat gold connectors, consider using balanced connections in your setup where it's possible. Now I will quickly explain the difference between balanced and unbalanced connections. An unbalanced cable consists of two connectors with two conductors each, connected by two wires inside the cable, a signal wire and the ground wire. Inside the cable itself, the signal wire is typically in the center of the cable, with the ground wire surrounding it. The ground wire serves two functions. It carries part of the audio signal and serves to shield the main signal wire to some degree from outside interference. It does a decent job of rejecting noise, but unfortunately the wire itself also acts like an antenna and picks up noise. Most common connector standards are RCA, used for many AV components, and 1/4 inch TS jack, or also known as phone plug. Unbalanced cables work great for connecting AV components, for instance, but because they are not very good at suppressing noise from outside interference, unbalanced cables should have a maximum length of 6 to 4 meters or 15-20 feet. A balanced cable, by contrast, has 3 conductors in the connector and 3 wires in the cable, 2 signal wires plus a separate ground wire. As in unbalanced cable, the ground wire still surrounds the signal wires and is used as a shield against interference. But what makes a balanced cable special is the way the gear utilizes that extra signal wire. Balanced cables use 2 signal wires. Both carry a copy of the signal, but the 2 copies are sent with their polarity reversed. If you sum 2 signals that are identical but are reversed in polarity, the signals cancel out, leaving you with silence. So why would you want audio gear that flips the polarity of your signal? In this case, because the receiving gear will flip the inverted signal back in its original orientation. But because both copies of the signal picked up the same noise as they traveled along the cable, and that noise is identical on the 2 wires in the cable, flipping the polarity of what arrives at the receiving gear will produce the original signal intact and noise which now has reversed polarity. Summing that gives you a welcome result: signal that is preserved and noise that is cancelled. Because of this, balanced cables can support much longer runs, 100 meters or 330 feet or more, though even shorter runs will often use balanced wiring to protect against noise. Standard connectors designed for use with balanced signals are XLR or TRS jacks. I based my explanation on the article which I read on aviom.com. I really recommend this article if you want to study this topic more carefully. You will find the link in the description. Now I had to decide how I will bring my idea to life. I had 2 options. First one was to use an operational amplifier, but that was too complicated as this requires extra PCB which you had to power up from somewhere. So I dismissed that option straight away. Then I remembered about Nutric D-shape adapters. Manufacturer describes them as miniature transformer balancing adapters, low-cost solution for unbalanced balanced line conversion and passive DI applications, where no earth or gain switching is required. I will take it apart and just use the same components and schematics for my project. Basically, this adapter has XLR female socket on one end and RCA socket on the other. It is worth noticing that the sleeve of the RCA socket is insulated from the rest of the adapter. Between 2 sockets there is a Nutric NTE1 professional audio transformer. According to the datasheet, it's a very low distortion, excellent frequency response audio transformer with 1:1 turns ratio. Also, you can see a 47 kilo ohms resistor soldered between hot and cold pins. My next step would be to get inside this sub. First of all, I'm going to take the 15-inch driver out. It is fixed with 8 boot screws. I will ask my assistant to tilt it forward while I'll be catching the driver from the front. Now, as the driver is safely extracted, I will disconnect the amplifier output cables as well as the cable which is linking motion feedback sensor with amplifier board. So that's the 15-inch low frequency driver. By the way, here you can see the motion feedback sensor glued to the inner part of the diaphragm. My next step would be to take the amplifier out. 14 wood screws undone. Volume control cable disconnected and amplifier can be extracted. As you can see, the back of the amplifier is covered with plastic guard, but I'm not sure what is the practical reason for that. Here you can see amplifier fully exposed. You can see the power transformer, mains socket, fuse, on and off switch and the amplifier board itself. All of these parts are mounted on a quite thick aluminum plate, which also working as a heatsink. Moving forward, I want to temporarily solder Nutric transformer and make sure that everything works and there is no unexpected problems before drilling a new hole for the XLR socket. I will follow the exact schematics of the Nutric D-shape adapter, where the white cable goes to the hot pin and the yellow to the cold. Also, I will solder a little bit of the cable to the ground pin so that later I could solder it to the amplifier's ground. On the opposite side of the amplifier board, I found a point which corresponds to sleeve of the RCA input and the point which corresponds to the tip of the RCA input. And one more point to solder ground cable from the XLR socket. Let's put an amplifier and the driver together outside the box, plug it in and connect it to the signal source. As you can hear it, it works, there is no audible distortion or mains hum. It's time to do some drilling. But before, I need to strip off all the components of the aluminum plate. First, I will unplug motion feedback extension, cut all the cable ties, remove volume control extension, and untangle remaining cables. Next, I will desolder the mains cables, and I can remove PCB after that. PCB is fixed with these two nuts, which are securing frequency cutoff and phase knobs. One screw which is securing RCA sockets. Two more screws securing aluminum heat exchanger. As amplifier board is still wired with the transformer, I also need to detach it. Now, when the plate is free, I can crack on with the drilling. I will use this Nutric 3-pin XLR socket, which requires 23.6 mm hole. So I've ordered this 24 mm mammoth drill bit. Before I start drilling, I need to clean the leftovers of the double-sided sticky pad. Best tool for this task is a wet baby wipes. Now I will mark the center of the hole, then make a punch so I don't lose the center when I start drilling. I will start from 1 mm drill bit, then a 6.5mm bit, and finally 24mm drill bit. I will use the file to smoothen out the edges. Next step would be to mark and then drill two 3.1mm holes, which will keep the XLR socket in place. Now I can prepare the socket itself. First I will trim transformer's wires, then strip and tin the ends. Next I will prepare a little extension which will link the transformer output with the amplifier board. I can assemble everything in one piece. Yellow wire to the cold pin, then white wire to the hot, and short black wire for the ground pin. Now I can solder that little extension which I've prepared earlier. Everything is very simple here. Solder the red wire that's positive, and then I'll add a little bit of a heat shrink. I will repeat the same procedure on the black wire, which is ground. And in the end, a little bit more larger diameter heat shrink, which will keep both wires together. Balanced signal is going to travel all the way up to here, which will stop any potential noise getting into the sub. I will use this 24mm copper pipe to fix everything together. Hopefully it will also act as an additional shield for the transformer. I will use some PVC tape to temporarily keep my structure in place. And in the end I will fill everything with a clear silicone. Silicone will prevent transformer from rattling because of the vibration inside the sub, and also will stop any air leaking through the socket. Now I have to leave it to dry for a day at least. 24 hours later, silicone looks solid and XLR socket is ready to be installed. I will secure it in place with 2 screws. As soon as I've done it, I can reassemble the amplifier. PCB can be fixed back on the aluminum plate as well as the transformer. Next step would be to solder AC input wires back to the amplifier board. Next I will solder ground wire to my newly installed copper shield. It must be grounded as any other metal part. Now I have to strip the insulation, twist and tin the ends. And when that is done, I can trim and solder my extension cable to the amplifier PCB at exactly the same points which I tried earlier. It looks like it's time to put everything back together. Return the driver to its place and screw it down. Put the plastic cover back, connect all the wires, stick the amplifier back in its hole and secure it with the wood screws. Now I can plug the power and signal cables in, and as soon the sub powers up, no, I wasn't expecting to hear that. I soldered everything exactly the same way as I did when I was testing. At this point I lost my ground. I couldn't understand what was causing the mains hum. I tried to change the wiring, add and remove ground wire, but it didn't help. Then I decided to build the whole D-shape adapter inside the sub. My logic was that it's a off-the-shelf product, therefore it must work. RCA connector will be replaced with the extension cable, which will be later soldered straight to the amplifier board. Because the transformer's wires are quite short, I will temporarily fix one half of the adapter with the tape to the inner side of the amplifier. I flipped the amplifier so I could get a better access and solder XLR socket to the transformer. Next, I will put the amplifier on its side so I could finish assembling the D-shape adapter. And once again, I have to trim the extension cable, strip and tin the ends, and solder it to the amplifier board. This time I will connect all the components outside the box to see if it works without wasting too much time. I think I'm ready to power up the sub. Oh no, it's sad, the hum is still there. I must be missing something. I left the sub in peace for a few days and waited until I can think clearly again. Then I came up with an idea. Maybe the wiring was correct all this time, but the position of the transformer is what causing the hum. I think I know what I'm going to try next, but before I do that I need to undo what I have done during my failed attempts. To make things easier for me, I've ordered a new transformer with untrimmed wires, which will help me to keep it outside the enclosure. Why I need to keep it out, you'll see in a second. So that will be my testing rig. I will connect it to the input of the amplifier and move it around to see if the position of the transformer is changing the strength of the hum. Here it is. The little transformer is picking up the noise from the high voltage cables, but especially from the main power transformer. It was possibly obvious for some of you, but for me it was quite a journey to figure everything out. And now that I know the cause, I need to find a solution to the problem. I needed to find out how can I protect my Nutric transformer from the influence of high voltage cables and power transformer itself. I realized that I need to shield the Nutric transformer, but the shield must be made of some specific material. I stumbled on a Wikipedia article about mu metal. I found it very interesting and I will share that information with you. Mu metal is a soft ferromagnetic alloy with very high permeability, which is used for shielding sensitive electronic equipment against static or low-frequency magnetic fields. Usually it consists of 77% nickel, 16% iron, 5% copper and 2% chromium. Mu metal objects require heat treatment after they are in final form. Annealing in a magnetic field and hydrogen atmosphere, which increases the magnetic permeability about 40 times. Bending or mechanical shock after annealing may disrupt the material's grain alignment, leading to a drop in the permeability of the affected areas, which can be restored by repeating the hydrogen annealing step. Mu metal was developed by British scientists in 1923 for inductive loading of submarine telegraph cables. Mu metal is used in electric power transformers to prevent them from affecting nearby circuitry. In hard drives, which have mu metal backings to the magnets to keep the magnetic field away from the disc. In magnetic phonograph cartridges to reduce interference when LP records are played back. In magnetic resonance imaging equipment, and much more. So I started looking for a transformer shield that is made of mu metal, and quite quickly I found this enclosure on Farnell Co. UK. It is made by a company called Vigortronics, and its price was acceptable. So I ordered a few units straight away. Parcel has arrived the next day, and here they are. 2 shiny metal boxes. Let's try and put the transformer inside one of them and see how it affects the hump. I have to desolder transformer again because wires must be threaded through the bottom plate to ensure that transformer is completely hidden inside the enclosure. Now I can solder back all the wires and reassemble the adapter. I will temporarily fix both parts of the enclosure with the gaffer tape. Right, let's see how efficient this enclosure is. As you can hear, this enclosure significantly reduces mains hum, and probably this would be enough in my case. But in addition to that, while I've been looking for the solution of the hum problem, I accidentally found another Nutric product which I had missed earlier and wanted to try. It is a Nutric NTL1 professional studio transformer with 1:1 turns ratio, but the most important fact is that it is fully shielded with a heavy mu metal housing. How did I miss that? The only thing which is a bit painful is the price. NTL1 cost about 3 times more than NTE1. I ordered one from Farnell Co. UK anyway, and here it is. Packed in this fancy box with the warning. It feels quite heavy for such a small component. The shield looks definitely thicker than the previous one. Okay, let's see, will this be the best option? Because the transformer is designed to be mounted on the PCB, it doesn't have any wires, so I have to solder them myself. I have downloaded datasheet from nutric.com to find out which pins I need to use. Pin 8 on primary winding represents white cable, which is XLR hot. Pin 6 on primary winding represents yellow cable, which is XLR cold. Pin 2 on secondary winding represents red cable, which is RCA tip. Pin 4 on secondary winding represents black cable, which is RCA sleeve. And pin 1 is the shield. So I prepared little extensions which I'm going to solder according to the datasheet and finish assembling my test rig so it's ready for testing. Finally, great success! The hum is completely gone. Let me remind you how it was without the shield. With Vigortronics enclosure and finally Nutric NTL1. I'm really happy that I found a perfect solution and I'm ready to finish my upgrade. Because NTL1 transformer needs to be fixed somehow, I will use D-shape adapter as an enclosure. I will use double-sided sticky pad to fix transformer to the inner part of the adapter. Then I'll solder the extension cable, which later will be soldered to the amplifier input. I've prepared two short jumper wires which will be linking XLR socket with the transformer input pins. Now I can start the assembly. I will temporarily leave one side of the adapter open so I can still gain access and solder jumper wires to the Nutrix transformer. After all wires have been soldered, I can close everything up and work on the next step, which is solder extension cable to the amplifier input. By the way, I've never mentioned which cable I am using here. It's a Van Damme Pro Grade Classic XKE Pro Patch cable. It's a reasonably priced cable with great specifications made for professional use. I will leave a link in the description if someone is interested and wants to know more about this cable. Now I'm repeating the exact same procedure which I have done numerous times while filming this video. It's measure and trim the cable, strip the insulation, and tin the ends. Trim the ends once again and finally solder them to the amplifier board. I will use 99% pure IPA so I could clean the excess of the flux around the solder joints. To make sure that everything works and that bloody hum is not going to suddenly reappear out of nowhere, I will quickly test everything before reassembling the whole sub. That's great, it works. One last touch before all the components go back into the box. I will add some silicone around the edges and at the point where the cable enters the D-shape adapter to stop any air leaks. After all, it's a closed type sub and it must be sealed. I must admit that when I decided to go ahead with this project, I wasn't expecting that it will take me so much time and effort, that so many things will go wrong, that it will be hardest video so far. But on the bright side, I have managed to finish it, find what I was doing wrong. I have learned a lot of exciting facts about mu metals and magnetic shields. And of course, I'll be finally able to connect my sub with my surround processor via balanced cable. One more test before I go. Great, now I'm going to enjoy a good movie and chill. I want to thank you for watching this video. Don't forget to subscribe to this channel and I will see you soon in the next video. Goodbye.